Welcome to the SIListra Systems video tutorial series. In this series, we'll explain how the SIListra Safety Transformer can be used in practice and how the concepts explained in the safety manual of the SIListra Safety Transformer can be implemented. Thereby, the video series serves as gentle illustration, giving an overview of the most important aspects of the far more detailed written tutorial distributed in your installation of the SIListra Safety Transformer. We do strongly recommend to read and work through the written format thoroughly in combination with this tutorial series. In this first video, we'll mainly look at the general setup of the tutorial. This means the general structure of the tutorial application, some of the concepts involved, and the difference between the simple tutorial and the full tutorial, the latter being explained in the following video. Also note, building the application is not explained here either, but rather in a separate video as well. We'll start with the general setup. For demonstration purposes, we choose a plant watering application for this tutorial. Of course, watering a plant is not really safety critical. However, this example is easy to understand, pictorial, and it fits the usual use case of the SIListra Safety Transformer quite well. That is, implementing a safety critical controller, receiving and sending black channel packages. And more importantly, the concepts demonstrated in this example application can be easily transferred to actual safety critical systems. Just replace the water pump with a medical device or a heavy machinery in a factory. But let's come back to the actual tutorial application. The general setup, which is as follows. We assume there's a plant that we want to keep watered, obviously without drowning it. For this, a sensor in the pod measures the water level, and the water pump can be turned on or off when necessary. Additionally, a controller is connected to both the sensor as well as the water pump. The water pump then is cyclically switched on if the water level is low, and off if the water level is high enough. It basically functions as a bang-bang or on-off controller. To make it easier to follow along the tutorial without having to buy a safe water level sensor, a water pump and a potted plant, or to build the complete control loop, we simulate all of these components in a second application. Therefore, the complete tutorial project consists of two executables that can be executed on the same or on different computers. First, the safe control unit called watering control is the main and safety critical application. It receives the water level from the sensor, computes whether the water pump should be turned on or off, and sends the water pump a new signal even when no changes shall be made. And second, the application called simulator that simulates the sensor, the water pump and the plant. If the pump receives a signal to turn on, the water level will increase, otherwise the simulation will slowly decrease it. Thereby, and as stated before, this tutorial treats only the controller as the safety critical component. That means data corruption and control for errors caused by random hardware faults must be detected during the execution. In case of an error, the system must go into a safe state, i.e., turn the water pump off and signal the user a problem has occurred. We want to realize this even with the controller running on consumer off-the-shelf hardware, of course using the SIListra Safety Transformer. Please note, the simulator will not be implemented safely, even though it is important for the overall safety of the complete system. For the sake of simplicity, our focus in this tutorial here solely lies in the control unit, and we assume we can simply switch out the simulation of the sensor, pump and plant with actual hardware. Plus, of course, these two applications need to be able to communicate safely with each other, which is the main difference between the simple and the full tutorial. The latter uses actual black channel protocols for the communication between the two executables. The simple tutorial, however, omits the black channel communication and combines both executables into one, where the data packages are represented as structs. Furthermore, the simple tutorial limits the safe functions that are transformed by the SIListra Safety Transformer to a single function of source code. However, this function does the main job, as it controls the pump algorithms to pass the data and the surrounding framework that is responsible for calling and verifying this function. The general code structure is shown in the following graphic, whereby, and as stated before, in this simple tutorial, the black channel packages are represented by structs. The main function of the watering control, highlighted now, runs in a basic loop which does: generate a single channel input packet containing the water level and its CRC, calculate the new pump state in the safe control task function, get the merged output packet and check if any errors occurred, simulate the watering by updating the water level in the plant. The safe control task function internally splits the control flow into two channels. The native channel being the standard code implementing the safe control task, and the encoded channel being the second encoded equivalent that the SIListra Safety Transformer has generated. After computing the new pump state in both channels, the results are merged into one output packet. Then, in the main loop, the output packet is checked for its validity. If it is not valid, a failure must have occurred in one or both of the channels. This sums up the general information of the simple tutorial. In the next video, we'll explain how to build and execute the tutorial application. Furthermore, the full tutorial expanding on the foundation described here is also linked below. And last but not least, we encourage you to read and work through the written tutorial thoroughly, because it expands on the simple tutorial video here by going more into detail on how the actual code is looking and how specific functions of code and structures are implemented. Visit our website for more information regarding the tutorial of the SIListra Safety Transformer 2.0 or contact us directly.